Alright, 4.5, number 15. It says, use Newton's method to estimate all real solutions of the equation. Make your answers accurate to 6 decimal places. So we'll finding the solution to this using Newton's. We need to know when it crosses, when it's 0, so when it crosses the x-axis. So on a test or quiz in Mr. Winkler's class, you're going to be given the initial guess. So you don't have to worry about figuring out where your first guess is going to be. And for our purposes, well, if we pretended we didn't have graphing calculators, what I would do is I'd just figure out, you know, if I plug in a couple easy numbers and see if it changes from positive to negative. So if I put in like 1, I got 1 plus 1 is 2 minus 1 is 1. So 1 comma 1 I know is a point. If I plug in 0, I get negative 1. So that actually worked out pretty well. So we know 1, 1 is a point and 0, negative 1 is a point. So it crosses somewhere in between 0 and 1. We know it does because we got a positive, we got a negative right there. Okay, so we could figure out maybe 0.5 or something would be a good place to start. So all of that would be if we didn't have a graphing calculator. But since we have a graphing calculator, instead of going through all that process, here's the graph. So it does cross between 0 and 1. Looks like it crosses closer to 1. So I would say that, I don't know, maybe 0.8 might be a good one to choose. 0.7, I'll go 0.7. Alright, so our Newton's method says that if we take, if we want to find the next x value, we take the current x value and subtract f of that minus f prime of that x value. Alright, so here are my values. I'll list them up. My first one is, what did I say, 0.7. Alright, so we're trying to figure out, you know, if this crosses there, we're going to pick 0.7, we're going to find a linearization, and then use that new x value to create another linearization, and then use that x value to make another one until it converges to 1 point. If we get the same number 2 times in a row, that means we know we have solved it correctly. Maybe I'll do like a, if it went like this, and this was my first guess. I make a linearization, and then I use that to make another linearization, and use that, and eventually it'll converge to getting the same number 2 times in a row. We're going to use 0.7, so it's going to be 0.7 minus f of 0.7 divided by f prime of 0.7. So the equation, so the derivative is 3x squared plus 1. So it's going to be 0.7 minus 0.7 cubed plus 0.7 minus 1. All of that divided by 3 times 0.7 squared plus 1. And that'll give us our next x value. Alright, so the shortcut would be to use your calculator. We don't have to type that in every single time. Let's store 0.7 in. So I'm going to type in 0.7 and then store right here. Store it for, I'll just do alpha A. So we're going to store it and then alpha A, and now 0.7 is 8. Alright, so we have it in there for A. So now I'm going to type in A minus the equation A cubed plus A minus 1 divided by 3A squared plus 1. Okay, so it's the current x value minus f of that value divided by the derivative of that value. And we know 0.7 is A, so this will give us our next one. Alright, so here's my list. 0.7. Now I have 0.682591091. Well, that's going to be my new x value right here. So I'm going to store that in for A. Now it's in for A. And now I'd have to type all of that over again. Unless you hit second enter. That pulls it up to this line, but we want that line, so hit second enter again, and now I bring it up to that line again. Now the new A value is stored already, so if I hit enter, it's going to plug in 0.68 and all that in for A and get us a new one. 0.682327863. Okay, store alpha A. Now we have to type that in again, so I'm going to hit second enter, second enter. Now we're going to plug the newest in to that formula. 0.682327838. So we're getting closer. These numbers are still a little different, so I'm going to store it, bring it up. Now I know the problem said to go out to, I think, 6 decimal places. We just went out to 1, 2, 3, 4, 5, 6, 7, 8, 10 maybe. And we got the same number twice in a row. So this is the answer to the equation right here. That's where this, if it was y equals that, crosses the x-axis. Now if I went back to my graph and I wanted to calculate the 0, second calculate 0, put the cursor on the left side of it, hit enter, put the cursor on the right side of it, hit enter, and we can put it right on top of it, hit enter, and I get 0.6823278. So we're even better than the calculator's estimate because it only went out that far and we went 3 more places. We're supposed to find all the values. That's the only time that that equation is equal to 0, so that's our only answer.